All right, so how do we perform basic function operations? What I mean by that is like addition, subtraction, multiplication, and division of functions. And then compositions. So I'm going to show you what function composition is, and then I'm going to tell you how to evaluate function compositions. All right, so first let's talk about those basic operations, addition and subtraction. So think if you have two different functions, f of x and g of x. So f of x, we'll let that equal 3x, and g of x we'll say is x plus 4. Okay, so the f and g, these are just names of functions. This is like a function of x, the function g of x. So we're going to have this new function, h of x, and we're going to say h of x is made by taking f of x and adding it to g of x. So what is this new function? Well, h of x, I would just take the function f of x, which is 3x, and add that to g of x, x plus 4. So now, I just combine like terms. H of x equals 4x plus 4. Now, if you think about the function 4x plus 4, that's just a line, right? It's a line with a positive slope. So what's the domain of this line?
4.
Like, the domain is all the places that the x's exist, right? So you could plug in any number from negative infinity all the way through positive infinity, right? You could plug in any number into x, and you would get a y value, right? There's never a time that you could plug in a number and it would be like error, undefined, or something like that. So we'd say that the domain here is all real numbers. And pretty much the only time that the domain is interrupted is if you're dividing by an x. So as long as you're not dividing by an x, the domain will be all real numbers. Okay. So what if that function h of x was made by subtracting g of x from f of x? Well, then we'd say that this h of x is equal to my 3x minus g of x is x plus 4. Now, I've written it like this for a reason. This is how almost everybody does this, and this is their first mistake. Because we have to notice that we're subtracting this entire function. So with subtraction, be careful that you subtract the entire function, right? Because now this negative is going to be distributed to the entire function. H of x is equal to 3x minus x minus 4. Okay, because we distributed the negative 1 that was outside that parentheses. So h of x is equal to 2x minus 4. Okay, 2x minus 4 is just a line, right? Yeah, it goes forever left, forever right. What's the domain of this? All real numbers. Okay, so let's have two new functions. Let's say f of x is equal to x squared minus 9, and g of x is equal to x plus 3. If I were to make a new function h of x by multiplying f of x times g of x, what would that new function be? So I take h of x equals x squared minus 9 times x plus 3. All right, since both of these functions are binomials and they're being multiplied, we're going to have to FOIL these things. So h of x is equal to x squared times x is x cubed. X squared times 3 is 3x squared. And then negative 9 times x is negative 9x. Negative 9 times 3 is negative 27. There's no like terms. So this is the function. Okay. That's f of x times g of x. And are we dividing by any x's? No. So what's my domain? All real numbers. Okay, so if I said h of x is made by taking g of x and dividing it by f of x, that would be h of x is equal to my x plus 3 divided by x squared minus 9. Now, I have to think, can I cancel anything since we're dividing? Well, in order to cancel, I probably need to factor that denominator first, since it's an x squared. So x squared minus 9 is a difference of two squares. So
minus 3x plus 3.
So yeah. So it's going to be h of x is equal to x plus 3 divided by x plus 3 times x minus 3. Well, now that I've done that, I can cancel binomials. Like if I have an x plus 3 in the numerator and 1 in the denominator, then they can cancel. So my h of x now is equal to 1 over x minus 3. So g of x over f of x is 1 over x minus 3. If I would have done this the other way and would have swapped them and had f of x over g of x, my answer would have ended up as x minus 3 over 1. So just x minus 3. No, so now for the domain, I have to think, okay, what number can you not divide by? You can't divide by 0. If you divide by 0, you get undefined, right? It doesn't work. So here, I mean, x is a variable, right? Like I could end up dividing by 0 if x equals a certain number. And the way that we find that is you always set the denominator equal to 0. But you do it like this. You say x minus 3, that cannot be 0. Okay? So if I add 3 to both sides, what number can x not be?
3.
X cannot be equal to 3. Because if I plug in a 3, I'll get 1 over 3 minus 3, 1 over 0. And that's undefined. And there you have what's called an asymptote. It's like just a line in the graph where the function can't touch it. So my domain is all the real numbers except 3. All right, here's a graph of 1 over x minus 3. Okay, this is a graph of that. And if you look, the x's go forever to the left and forever to the right. So that's all the real numbers, except there's nothing right there on that line. And that's at x equals 3. Okay? If you plug in a 3, you get an undefined, so there's an asymptote. That's that invisible line that's blocking the function. All right, so before we go into function composition, I want you to think about this. For f of x equals 2x minus 8, how would you find f of negative 2? So, what's the difference between f of x and f of negative 2? Like, just in the way that these two things look. This has an x.
There's an x value.
This has a negative 2. Right? So if f of x equals 2x minus 8, if I replaced this x with a negative 2, then I'm also going to replace this x with a negative 2, right? So f of negative 2 would be 2 times negative 2 minus 8. So whenever we do stuff like this, we call that evaluating, because we're supposed to come out with a number. Okay? So f of negative 2 equals 2 times negative 2 minus 8, which is negative 12.
That was easy.
Now, that's not the only thing that we're going to do. We're going to now take what we've known how to do that, and we're going to do it with function composition. Okay, so function composition is whenever you take two functions, right? And the output of one becomes the input of the other. So let's imagine that we just take some x, right? And we're going to run it. These are function machines, okay? We're going to run it through the g function, and its output would become g of x. Now, as you can see, this output is falling into the f function. So g of x falls into the f function, and what comes out is f of g of x. So, again, this is read, okay, so this is read as f of g of x. Another way I can write that is with this like fog thing. F of g, and then today we'll do of x. Yeah, it's like a little open circle. They're not multiplied. Now there's also, I mean, we could have g of f, g of g, f of f. Any variables really. I'm just showing you how they're read. So f of g of x, the same thing as f of g of x. All right, let's see that in action. Let's take two different functions. Let's take f of x is equal to x squared minus 1, and g of x is equal to 2x minus 3. Okay, so we're going to find f of g of 1. Whoops. So f of g of 1. Then we'll spin that around, and we'll do g of f of 1. And let's also do f of g of negative 3. So look, again, guys, the only difference between f of g written like this and f of g is just the way it's written. That's all. I prefer to always get it down into this version because I feel like this shows you what to do first. Like the one right now is with the g, right? So if I'm going to find f of g of 1, the first thing I better find is g of 1. Okay, so now I have f of, to find g of 1, I would go to my function g, and what do you think you're going to do with that x? You're going to plug a 1 into that x. So it's 2 times 1 minus 3. So g of 1 was negative 1. Okay, now this looks like what we were doing earlier, right? If you have a function f and you're saying f of some number, all you do is plug that number in for f. So I have negative 1 squared minus 1. Well, negative 1 squared is positive 1. 1 minus 1 equals 0. So f of g of 1 equals 0. Alright, so g of f of 1, we start by plugging in 1 into the f function. So that's g of 1 squared minus 1. 1 squared is 1, minus 1 is 0, so this is g of 0. So now I'm going to plug a 0 into the g function. 2 times 0 minus 3 is negative 3. So g of f of 1 equals negative 3. Okay, in this example, f of g of negative 3, I'm going to change it to like this, f of g of negative 3. That way it's just easier to see what order I should be doing the things in. So g of negative 3 would be 2 times negative 3 minus 3. So this is 2 times negative 3 is negative 6, minus 3 is negative 9. So f of negative 9 would be negative 9 squared minus 1. What's negative 9 squared? 81 minus 1. So f of g of negative 3 equals 80.